question is asking, the amplifier in figure 10.3a is biased to operate at GM is equal to 5 milliampere per voltage and has the following component values. Rsig is equal to 100k ohm, Rg1 is equal to 47 mega ohm, Rg2 is equal to 10 mega ohm, Cc1 is equal to 0.01 microfarad, Rs is equal to 2k ohm, Cs is equal to 10 microfarad, Rd is equal to 4.7k ohm, RL is equal to 10k ohm, and Cc2 is equal to 1 microfarad. The question is asking us to find out the AM, FP1, FP2, FZ, FP3 and FL. Okay, now let's go and see how to find out them one by one. And this is the circuit we are looking at. Okay, one second. So the circuit we are looking at is this A circuit 10.3A, the top circuit right here. And in this one, first we are interested in finding the AM. AM is the gain. To calculate the gain, we have to use this equation, that is negative the equivalent resistance of this Rg1 and Rg2, that is Rg divided by Rg plus this resistance Rsig times the transconductance Gm times the load resistance and this Rd. RL is right here, Rd. RL parallel Rd. Rd parallel RL. Okay, so this is the equation. Now from the provided values, we don't have the Rg available. We have Rg1, Rg2 available. We have to find out the equivalent resistance, that is Rg, and then Rsig is readily available, that is 100k ohm resistor, and then Gm is provided to us 5 milliampere per voltage, Rd is provided to us 4.7k ohm resistance, and then RL is provided to us 10k ohm resistance. The only thing we have to find out is Rg. To find out the Rg is nothing but the equivalent resistance of this Rg1 and Rg2, both of them are in parallel, so we have to just do the parallel combination. So Rg1 parallel Rg2, which is nothing but Rg1 is 47 mega and then Rg2 is 10 mega, and the equivalent resistance is, when you have parallel, the calculation is product over sum. You have to multiply and add in the denominator. When you do that, you will end up getting 8.25 mega ohm resistance, and this is the equivalent resistance of these two resistance. Now we have to just plug it in this equation and find the gain. Now if you plug it in, AM is going to be equal to negative, and then here we have Rg, that is 8.25 mega, and in the denominator we are going to have Rg, that's 8.25 mega, and then plus Rsig is provided to us, that is 100k ohm resistance. Rsig is 100k ohm resistance right here. Plug it in, and then we have Gm, that is 5 milli, and then we have the Rd parallel RL, that is 4.7k parallel 10k. 4.7k parallel 10k, and if you calculate, you will end up getting negative 15.8 voltage per voltage, and that's our gain. Now the next thing is we have to find out the frequency at pole 1, pole 2, and then at 0, and then pole 3 as well, and then we have to find out the FL as well. Okay, now let's go ahead and find one by one. Pole 1, so we have to, when they say frequency at pole 1, that is, we have to look at each capacitors right here. So for the first one, we look at the Cc1. Let's do that. The original equation is basically you have to put omega p1, that's the angular frequency, that is equivalent to 1 over Cc1, and whatever the resistor related to is, in this case here we have Rsig and Rg in between them, so this is going to be Rsig plus Rg. Okay, but the question is asking for the FP1. Omega p1 is equal to 25 FP1. Okay, omega p1 can be written as 25 fp1, and that is also equal to this same thing, cc1 Rsig plus Rg. So now we have to rearrange this one in terms of fp1. So we are going to have fp1 is equal to 1 over 25 cc1 Rsig plus Rg. Now we have to plug in all the values. The values are readily available. So 1 over 25, and the cc1 is provided to us right here, 0.01 microfarad. So put that one in right here, micro. And then we have to put Rsig and Rg as well. Rsig is 100k, and then Rg we just calculated before, that is 8.25 mega. Okay, plug them all in and solve for the frequency, and you will end up getting fp1 to be 1.9 hertz. Okay, this is frequency at the pole 1. Now frequency of pole 2, right here we have the capacitor CS and then RS. The equation right here is going to be GM plus 1 over RS over 25 CS. All the values are available. GM is 5 milli, and the 1 over RS is provided to us, that is 2k, divided by 25 times CS. CS is provided to us, that is 10 micro. Okay, solve for this one, you will end up getting 87.54 hertz. Okay, and then we have to find out FC and FP3 as well. Let's try FP3 first. Let's go to new page, FP3, and that is pole 3. We have to look at the next capacitor, that's right here, CC2. At CC2, what are the resistors related to it? The resistor related to this one is the load resistance and also this RD. Okay, so the equation is gonna come out like this. It's also omega p3, and then you can rearrange as we did here before. You can put omega p1 and 25 p1, like we rearrange this like this. Here also similar thing, you have to just rearrange this, but here we will, for the one we are looking at here, CC2, at this one the resistors are RD and RL. For the previous one we had Rsig and Rg, that's why we added in the denominator Rsig plus Rg. But for the one we are looking at right here, the resistors are RD and RL, so we have to add that one. And now we are gonna put 25 FP3 instead of, before we have FP1, now we are going to put FP3, and this is going to be CC2 because that's the capacitor right here. Okay, that's a difference. So okay, let me double check if the sound is coming. My mic wire. Hello, hello, hello. Okay. So we are looking at FP3 and then equation. Let's write the equation first. This is going to be 25 times CC2 and then RD plus RL 1 over 25, and then CC2 value is provided to us. That is 1 microfarad, so we put 1 micro right here. And then RD, RL, both of the values are available, 4.7k, 10k. 4.7k plus 10k, and that is it. We are just solve for this and you will end up getting 10.827 hertz. Now we have found out fp3. Now we had to find out f0, that is fc. fc is, when they say fc, we have to look at the cs and rs. The equation here, we have to look at the resistance related to it, that is in this case only rs right here. So it's going to be exactly looking like this, except the cc. Now we are going to have the capacitor cs, and also the resistance is going to be just rs, because we don't have any other resistance between the capacitors, only the rs. So we are going to have this one to be 1/2 cs rs, and we just have to plug all the values. 2 and then cs is provided to us, that is 10 microfarad, so put 10 micro right here, and then rs value is also provided to us, that is 2k, and so for this one you will end up getting 7.94 hertz. Okay, finally we have to find out this fl value. This fl value is nothing but all the pole frequency square, so fp1 square plus fp2 square plus fp3 square minus 2 times the zero frequency square, that's fc square. Plug in all the values. We know fp1, that is, we calculate over here, that is 1.9 hertz. So 1.9 square plus we calculate fp2 to be 87.54 square, and then we calculate fp3 to be 0.8. fp3 we got 10.827, so 10.827 square. Let me put it in a nice way. Square, and then minus 2 times the fc we calculated, 7.94 square. Okay, from this one we can calculate the fl, and if you find out the fl, that comes out to be 87.51 hertz, and that's our final answer. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.